Good morning. I apologize for having to have class this way, but for whatever reason, I am not able to stay on a Zoom. I don't know why, but I figured before class started, maybe I could get through a couple examples and send you this video so that you would not be without any instruction for the day. So I'm not going to be able to fix any errors. If I misspeak, I'm just going to have to keep going. I'm pressed for time, so please bear with me. I am on page 13, and we're taking a look at part 3 of our solving equations, and this is solving by substitution. So you'll notice that in these equations, we have two trig functions, and one of them is typically squared, so we can swap it out with something that's equivalent using a Pythagorean identity. So we know that sine squared is equal to 1 minus cosine squared. So we can change this out, this sine squared, for 1 minus cosine squared. And we would distribute this 2. So 2 minus 2 cosine squared minus 2 minus cosine x equals 0. So I did move this 2 over to this side and became a minus 2. I moved this plus cosine to this side. It became negative cosine. So now I have this not very well simplified but quadratic equation. So once I simplify it, I will be able to factor it like we did yesterday and move forward. So the 2 and the negative 2 are going to cancel, and we're left with negative 2 cosine squared minus cosine. So we can factor out negative cosine, and we could be left with 2 cosine minus, or plus, sorry, 1. Let me just check that I did that correctly. So we factored out a cosine, negative cosine. We were left with 2 cosine. That makes sense. Okay, perfect. So now that it's factored, we set each factor equal to 0, and this looks a lot like what we did yesterday. So negative cosine equals 0. I realized I forgot the x right there, so I just added the x right there. 2 cosine x plus 1 equals 0. So this means that the cosine of x is 0, or the cosine of x is negative 1/2. So then we start looking for angles that have those values for cosine. So the cosine is 0 at pi over 2 and 3 pi over 2. Notice we're on an interval here from 0 to 2 pi. So we want to find there's no general solution. We just want to find the angles in one trip around the circle that would work. So this one is pi over 2, 3 pi over 2. Cosine is negative 1/2 in quadrant 2 and quadrant 4 with a, let's see, 60-degree reference angle? Yeah. So that would be 2 pi over 3 and 4 pi over 3. So that is those two solutions. So that would be our first example all worked out. Normally I'd ask if there's any questions, but I can't. All right, let's look for another one that looks fun. So this one has, down here, this one has secant squared and tangent in it. So I'm looking at letter E now. So I'm going to have to figure out an identity that I could plug in for secant that's in terms of tangent. So I'm going to derive that right over here real quick. You might know these. I told you I do not. So if I divide everything by cosine, we'd have tan squared plus 1 equals secant squared. So tan squared x plus 1 is being plugged in for secant squared, minus 2 tan x. I'm going to move that 4 over, make it a negative 4, and it's equal to 0. So if I clean this up, I'll have tan squared x minus 2 tan x minus 3. And factoring would give me tan minus 3 tan plus 1. So that means that the tangent of x is equal to 3, or it's equal to -1. So I'm going to deal with -1 first because that's the one that is something I can actually work with. So tangent is negative in these two quadrants at pi over 4 reference angles. So we're going to say 3 pi over 4 and 7 pi over 4. So those are done. Now we're being asked to work in radians. I'm glad I picked this one. So typically if we wanted to solve this, we just use a calculator and do tan inverse of 3, and we get some angle. I don't know what it is, but it doesn't matter. But we're asked to work in radians, and the calculator is not going to do that. It can, but I haven't shown you how, and it's really not important. So I think the way we could handle it is just by doing x equals the tan inverse of 3. That's my first angle. And then the other, I would want to add 180 to it, or pi, I guess, in this case, because we're in radians. So it would just be whatever that answer was plus pi. So if we were working in radians, we could just, or excuse me, in degrees, we could just go to a calculator and get tan inverse of 3. Actually, I'll do that for you, just so that we see the answer. So tan inverse of 3 would be like 71.57-ish. And then we could add 180 to that to get the other angle in quadrant 3, and that would be 251.57-ish. Okay, so that would be in degrees, but we're not asked to answer the question in degrees. We're asked to answer it in radians, so we just leave it as tan inverse of 3 and tan inverse of 3 plus pi. Okay, I'm going to stop here. I'll make a separate video for part 4 so that I can at least get this sent out to you. I will be able to monitor my email, so if you need anything, you can certainly try to email me, and hopefully I'll be able to resolve this maybe before the end of the class period, but if not, at least we're moving forward. So I'm feeling good about that. Remember that if you need to hear anything again, you can always back the video up or watch it again. So feel free to do that. I will make sure that I send you a key for the first 2 parts. If I didn't already, I'll have to check so that you can check those that you've already done. And at the end of the day today, I'll make sure I send out a key for these 2 parts so you can check them as well. Okay, I do have those ready to go, but I want to give you a chance to try the rest of these examples on this page by yourself. Okay, so work on those while I make a video for part 4, and I will come back with that in a little bit. Thanks so much for your flexibility and patience today. I really appreciate it.